so right now we're going to do some videos, do a video on some examples from section 2.3 log information. So this is section 2.3 examples that you can use to help you solve some of these problems, some guidance. And the first one we're going to look at is problem number 6. And in problem number 6 in here, we have the log base 6 of 1 over the 5th root of 36. And we are asked to evaluate this log without a calculator. To evaluate a log without a calculator, you have to use the properties of logs. There are several of them that are in there, but the most important one is going to be this one. This property where it says the log base b of b to some power is simply just the power. And the reason why this is because the log function base b is the inverse function of the exponential with base b. So this is literally the composition format of inverses. And by definition, two functions that are inverses, if I compose them, I should get the value of x. And x just happens to be the exponent up here. So whatever that exponent is up here, that's going to be the answer if I do something of this type. But this property only works if the base number on the log is equal to the base number on the exponential. And when I look over here, the log has a base number of 6, but this is not base 6. It doesn't look like base 6. So we need to change the way it looks using the exponent rules and such to get it to be into the log base 6 of 6 to a power. I need to find that power from that. So we take this quantity right here and we use exponent rules to get this to look like 6 to a power, if possible. If it is not possible to do, then it's not possible to do. First things first, let's go off to the side. Let's figure out what the 5th root of 36 is. Well, by 5th root, we already know that this is 36 to the 1/5 power. So based off of that, 36 we know is 6 squared to the 1/5 power. A power raised to a power we multiply, so now this is 6 to the 2/5 power. But that's what this equals, and I had 1 over that. So to bring this quantity to the top of the fraction, I need to make that exponent negative. And so this quantity right here is 6 to the negative 2/5 power. And once it's in that form, then I can invoke this rule, base 6, base 6. The answer is just the exponent negative 2/5. And that would be your answer to this problem. And the thinking that goes behind it. Let's look at number 15. In number 15, we have the natural log of 1 over e. If I'm trying to solve this without a calculator, to evaluate without a calculator, then I have to invoke these rules over here. And this is basically the main rule right here. So the natural log simply means the log base e. And so we need to change this to e to a power. So this one's a little bit easier. 1 over e is equal to e, and this is the power of 1. So when I bring it to the top, it becomes negative 1. So this fraction is just simply negative 1. The bases are the same. The answer is the exponent. And that's how you can do something like that with a natural log. Same process, it's just a log. You guys wanted to see number 22. Number 22 looks like this, 10 to the log of 14. Remember, if there is no base number written on the log, then it is log base 10. It is the only log that you do not need to write a number for. It is the common log, but it is base 10. This one uses the other version of composition. So this would be like f of g of x. And this one uses it as if it was g of f of x. So it uses the property the base number to an exponent with the log of the same base. These also offset each other because they're opposite operations. You're doing g of f of x, and so since they're inverses, you simply get x again by definition. So we need to get this base number and that base number to agree. The common log base 10 is already the same as this base, so they cancel out the operation, and you're left simply with the 14, and that would be the answer. So that's pretty much what happens there. You just need to make sure that the base numbers are the same, and then whatever is this argument, that's your answer. We were also asked to do some graphing. So the next two examples are on graphing, walking you through the graphing technique for the types of functions that you're going to have. Here's number 52. I got f of x is a negative 3 times the log of 1 minus x plus 1. Now, in this example right here, this log has no base number written, so it's automatically base 10. If it's not written, it's a base 10, it's the common log. You can actually put it in if you want to help you remember. So what was the technique I wanted you to do for graphing? Well, first off, you're probably going to be asked to list all the transformations, but we won't do that right now. Actually, we can. So going off on the inside right here, the first step we do is we take the argument, 1 minus x, set it equal to 0, solve for x, and that number serves two purposes. That number tells you that you're going to go to the right 1 unit, and then it's also going to be a number that we're going to put into our table in some fashion, but we'll talk about that later. And it's also reflecting references to vertical asymptote, and we'll talk about that in a minute too. The x is negative, so clearly I have a reflection across the y-axis. Then I come out here to the 3. Since it's bigger than 1, I have a vertical stretch by 3. And because out here in the front is also negative, that's a reflection across the x-axis. And then the plus 1 means I'm going up 1. So these are all the transformations assigned in that problem right there. The right or left determines the vertical asymptote. So I already know that not only this here is I'm going right 1, then it also means that I have a vertical asymptote at x equals 1. So when I graph this, I'm going to put a dotted line at 1. The next thing you want to do is you want to make your table. Before I can make the table, I need to isolate this log. So think of this as a y. I'm going to subtract the 1 and then divide by the negative 3. So I'm going to get y minus 1 divided by negative 3 is this log base 10 of 1 minus x. At this point, you can put the base 10 here. This is where we use the box, circle, triangle to change forms. I have a log. I put it into exponential form. Claire kills me. So that means the base, now this is the box. This over here is the circle. This is the triangle. So I have 10, and I'm going to change these signs just a bit. I'll just leave it. Y minus 1 over negative 3 is 1 minus x. We got to solve this for x. So moving things around, I can move this x over here, it becomes positive, move this quantity over here, it makes it negative, and I get x equals 1 minus 10 to the y minus 1 over negative 3. So you solve for x, and in our table, we're going to plug numbers in for y to work this out. This is the exponential form of this log. these two things are the exact same function. Just one's in log form and one's in exponential form. And exponential form is easier to graph. You're going to pick numbers for y, just like you do in any kind of exponential thing. What number makes the exponent 0? And you can see that it'll be 0 when y is 1. And that's your middle number. That's how we graphed exponentials. We found when the exponent was 0, and that was the middle of my table. All you have to do now is just pick two numbers above and two numbers below, and it doesn't matter which ones you pick. It's totally up to you. So we can pick, because we have a 3 here on the bottom, you might want to pick numbers that will give me a 3 on top so I can have integer things. So give a little thought between it. So whatever I pick for y, I'm going to subtract 1 from it. So I want one number bigger than the 3. So if I plug in 4, I'll get a 3 here. So I'm going to plug in 4. And so then after 3 would be 6. And so what number did I plug in here to get a 6 would be 7. Numbers down here, you can also see every 3. You can go every 3 this way. So if I do that, then this over here would be -2. And then 3 more this way would be -5. So these are the numbers I would plug into this equation right here to find the x's that go with it. And why I chose what I did. Because I had that 3 on the bottom. I don't want to have fractional answers. So I wanted to pick y's that gave me integer answers. Just think about it a little bit before you jump in. Once you have these numbers chosen, just plug it in and work it out. If I plug in a 1, I get 0. The exponent is 0. End of the 0 is 1. 1 minus 1 is 0. If I plug in 4, the top will be a 3. 3 divided by -3 is -1. So I have 1 minus 10 to the -1. Write it out if you need to. This is 1 over 10. So this is going to be 9 over 10. This will be 1/10. 1 minus 1/10 is 9/10. If I plug that in, that will be a 6 on the top. Divided by -3 gives me -2. So I have 1 minus 10 to the -2. That will be 1 over 100. So this is 99 over 100. Now remember, we had a vertical asymptote was equal to 1, and we can see clearly that these numbers are getting closer and closer to 1. It should confirm what we're talking about. Plug in the -2 up in here. This gives me -3 on top, -3 on the bottom, gives me +1 exponent. So that's 1 minus 10, which is -9. And if I plug in -5, gives me -6 on top, divided by -3 is +2. So then I have 1 minus 10 squared, which is a -99. So there's my table. So once you do that, you just need to graph it. I'm going to move this off to the side here real quick. Get a graph going in here. We can see that I have a lot of negative on the x's, mostly on the negative side. I don't need a lot of x because I have at 1, I have a vertical asymptote at 1. You should draw it first. Make sure you scale everything. This is pretty large, okay, but we can go out this way. I'm obviously not going to go out to -99. So 0 goes to 1. 9/10, which is about right here, goes to 4. And then the next one, 99 over 100, goes to 7. So we're even closer there. -9 goes to -2. And that's pretty much all we get. Because I'm not going to graph -99. But you can see the shape. It gets closer here. It comes down through there. And it comes over here to that one. So just do the best you can on it. Label your center point and some other point. Scale your axes so I can see it. I'm not doing it here. Label the vertical asymptote. Make sure you just put the x equals 1 on it and it's a dotted line. Other than the scaling of the axes, this graph would be done. And that's what it looks like. There was one more graph you guys wanted to look at. Look at number 54. F of x equals the natural log of x plus 1. Oh, if they ask you to talk about the domain and all that kind of stuff, you can see clearly here that the range is going to be all real numbers, and your domain is all the x's less than 1, and your range would be all the real numbers. So in log graphs, you have a restricted domain, and the range will always be all real numbers. Now, number 54. Same process. This is a natural log graph. I'm not going to list the transformations, but I do want to find my vertical asymptote. Remember, the vertical asymptote is determined by right or left, which means take the x plus 1, set it equal to 0, and you get -1, and that will be your vertical asymptote. It's left 1, but that's also the vertical asymptote. Remember that this is y, a natural log is log base e. So if it helps you to rewrite it this way, it's useful to do. My log is already isolated. So using the box, circle, triangle, I can change to exponential form by simply taking the box to the circle. So it'll be e to the y equals x plus 1. Subtracting the 1, solving for x, I get -1 plus e to the y, or e to the y minus 1, same thing. This is the exponential form of that log. We make our table, just like always. And then we want to find the numbers we're going to plug into our table. The center numbers when that is 0. Y is 0 when it's 0. Pick 2 numbers above, 2 numbers below. And at this point, you will need to use a calculator. So you use your calculator for this to figure out these values. Because it's a natural log, and you can use calculators are always for natural logs or base e. But I want to see this table though. So I want you to make the calculator, use the calculator with this table, not any just random table. So when it's 0, e to the 0 is 1. 1 plus a -1 is 0. So we know that's there. And the rest of these are all going to have values of e in it. If I plug in a 1, I get a -1 plus e. So you can use your calculator. E is 2.718. Yeah. And so 1 minus that would be 1.7. Just a tenth place is all that you need for graphing. And just use a calculator for the rest of it. And you're going to simply type in this thing right here. It's a -1 plus e to a power. And I'll put 1 in there right now so you can see it. I got a glare, but 1.718. Now, instead of retyping it all again, I can just hit Control Z, and I kiss it back in edit mode and just change that 1 exponent to a 2, and hit Control Enter, and this one is going to be 6.4, and just keep repeating that process, changing the exponent each time. Negative 0.6. And then the last one. Negative 0.9. And we see clearly that this is my vertical asymptote, and then I got one side is getting closer to -1. So this one is going closer to -1. So the vertical asymptote will be over here. And we can graph it now. Remember, this is indeed a log. We have to go out to about 6. And a couple this way, a couple this way, and one this way. I have a vertical asymptote right here at x equals -1. It goes through 0, 0. At 1.7, which is about here, I got a number of 1. At 6.4, 6.4, I got the number 2. As I get closer, it's moving down. Remember, logs are going sideways, okay, unless you have some kind of weird reflections. There's my log graph. Label the center point and one other point. And there's my graph. Again, scaling the axes, because you need to scale the axes too. So there's your graphs. This is what I'm going to be looking for, okay, when I grade your tests and stuff. So we'll do more examples together.